Okay, pre-calc. So we're going to jump forward quite a bit, partially due to the fact that I'm not going to be able to see you guys as much due to this new schedule. So I want you to jump to solving trigonometric equations, which remember this is in the packet that's uploaded on Google Classroom. Unfortunately, I wasn't able to print it out for you for obvious reasons. And so what we're going to be doing now is we're going to be solving equations that have trigonometric functions in them. And we've essentially kind of done this in the past a little bit. Right? But we're going to start off by just taking a look at the graph of a sine function. Okay? And really, this graph is going to look like this, but what I like to use really instead of this graph is actually our unit circle. So go ahead and make sure that you have this available. What the graph does show is that when we're solving for a sine function, and this also includes cosine functions, our answer is going to be between 0 and 2 pi. And then our answers are going to kind of repeat after that. Right? So what you'll notice for all of these trig functions is that you're going to have some restrictions or intervals where your solution has to be found. So for example, this first one says, give the solutions to the equation sine of x equals 1/2 on the interval 0 to 2 pi. So it basically wants us to figure out at what angles is sine equal to 1/2 in the interval 0 to 2 pi. So our unit circle covers that entire interval. So I just go here and I would look for where is sine equal to 1/2. So I go around, it looks like pi over 6, right? And then our other answer, I think we got one more. It looks like 5 pi over 6 also has, it's a 5 there, a sine value of 1/2. But sometimes we'll have intervals that are greater. Like here it says, give the solutions to the equation sine of x equals 1/2 on the interval negative infinity to positive infinity. So in this scenario, we have to actually go all the way back and think about our coterminal angles, which are angles that end at the same exact spot, because those guys are going to have the same exact trig value. So obviously the two angles we know that are going to be from 0 to 2 pi are the ones we already found, pi over 6 and 5 pi over 6. But now, because our interval goes from negative infinity to positive infinity, we need to cover every single possible angle. The way we're going to do that is, remember, to find a coterminal angle, we just add or subtract a full rotation. So that's 2 pi in radians. So I'm just going to say plus or minus 2n pi. That n just stands for any number we could possibly think of, and it has to be an integer. So it could be 1, 2, 3, 4, and so on. And then over here we got plus or minus 2n pi as well. And that just tells us that we are going to have that many possible answers, well, an infinite number of solutions. And I'm actually going to take off this negative, and the reason being is just so, because we could actually put a negative in for the n, and that would be kind of the same thing as plus or minus, just cleans it up a little bit. Okay, so what we just did is we noticed that the interval has an effect on how we end up writing our answer. Okay, so today we're going to just look at some pretty basic ones. So the way that we solve these guys, we have to isolate them first. And the two examples I showed you right there, sine of x was already by itself. So whatever our trig function is we have to make sure that we isolate it. So in this case, we have 5 cosine of x plus root 2 equals 3 cosine of x. So first, I'm going to subtract 3 cosine of x. And I'm going to get 2 cosine of x plus square root of 2 equals 0. Then I'm going to subtract square root of 2. And I'm also going to divide by 2. And it looks like once I'm isolated, I get something that looks like this. Right? So take note of our interval here. It's negative infinity to infinity. So what we need to do here is first we're just going to look at our unit circle and look for where is cosine equal to negative square root of 2 over 2. It looks like at 3 pi over 4 and also at 5 pi over 4. But because our interval is from negative infinity to positive infinity, we're going to have to add 2n pi to each of these guys to represent the fact that we have an infinite number of solutions as long as we just add or subtract 2 pi to either of those answers there. Okay, so for number 2, it's kind of similar to what we did in number 1. We want to just isolate our trig value here. So I'm going to add 3 tangent, right? And I get 6 tangent of theta plus 2 root 3 equals 8 root 3. I'm going to subtract this 2 square root of 3 and get 6 tangent of theta equals 6 square root of 3. And then divide by 6. And it looks like I got tangent equals the square root of 3. Okay, so once again, once you isolate, okay, you just go to your unit circle and you look for where is tangent equal to the square root of 3. Okay, so I see 2 spots. One of them is pi over 3. And then our other guy, let's see, do we have another one that has root 3? And we also have, I think it's this guy right over here, 4 pi over 3. And then what we have to take into account is that there's all these other options because our interval goes from negative infinity to positive infinity. But remember, right, tangent repeats itself a little bit quicker than sine and cosine. Remember, the period for tangent when there's no nothing affecting it is just pi. So with this one, instead of 2n pi, we're just going to add n pi to each of these guys. Right? And those would be our solutions. Right? So what I like to do in scenarios when I have any reciprocal functions is I still isolate them, but then at the very end, I turn it into one of my main trig functions, sine, cosine, or tangent. Just makes it a little bit easier here. So for example here, for number 3, first thing I'm going to do, I'm going to go ahead and multiply 4 on each side. So I'm going to have the cosecant, I'm just going to put an x there, minus 6 equals negative 4, and then I'm going to add 6. And then to finish off, I know that cosecant of x is the reciprocal of sine of x. So if cosecant is equal to 2, sine of x is equal to 1 over 2. Right? The reason I do that is because remember our unit circle has sine and cosine all set up for us. So where is sine equal to 1/2? Looks like pi over 6, as well as 1/2 looks like 5 pi over 6. And because our interval is from negative infinity to positive infinity, we're going to add 2n pi to both of those answers to represent that we could add or subtract a complete rotation of 2 pi infinitely to get more answers that would have the same solution. Okay, so go ahead and try number 4 out on your own. Right, so pause the video and unpause it when you're done, and then I'm going to get rolling on this guy. I'm going to subtract secant of y, divide by 6. And reduce that guy. But remember, what I like to do, I think it's a little bit easier if we go ahead and get one of our normal trig functions rather than the reciprocal. So I have to rationalize this guy right here. So that means multiply top and bottom by root 2. So it looks like I'm going to get negative 3 square root of 2 over 4. Okay, so cosine is equal to negative 3 square root of 2 over 4. Okay, and when we go ahead and try and find that, which I think for some reason seems a little off. Let me think. I figured it's something a little weird. 6. Here it is. So sorry about that, but if you caught this early and you've been waiting, sorry, but this should actually be root 3, right? right? And that'll make this a 6, and that'll change this to negative root 3 over 2. Okay, that makes more sense. Okay, so we're isolated now, and now that we have cosine, right, we're just looking for, on our unit circle, where is cosine equal to negative square root of 3 over 2. So negative square root of 3 over 2 for cosine is going to be, looks like at 5 pi over 6, as well as negative square root of 3 over 2, 7 pi over 6. And because our interval is from negative infinity to positive infinity, we're going to do that 2n pi again for each of those guys. So there's our two solutions, right? So other times you'll notice that we have intervals that are a little bit more specific rather than just negative infinity to positive infinity. So for example, number 5 here, right, our interval is 0 to 2 pi. We still do everything else the same way we've been. So it's going to be 2 tangent of a equals negative 2 divided by 2. And we get tangent of a equals negative 1. So then we're going to go ahead, and we know we're only going from 0 to 2 pi. We're looking for where is tangent equal to negative 1. Remember, tangent is sine over cosine. So it looks like we're going to have 3 pi over 4. And our other guy will be 7 pi over 4. In this scenario, because of our interval, we are not going to go ahead and do the plus 2n pi. Remember, we only want our answers from 0 to 2 pi. For number 6, it gets even more specific. I'm going to go ahead and isolate this guy. If you take a look at our interval real quick, it's pi to 3 pi over 2. So that's only one quadrant we're looking at here. So let's see what we can do. So I'm going to go ahead and get something like this. Take the square root of both sides, and I'm going to get sine of u equals, this is going to be plus or minus the square root of 3 over 2. Okay? So we want to look on our unit circle and decide where is sine equal to positive or negative square root of 3 over 2, but it has to be between pi and 3 pi over 2, so that's this area right here. And it looks like there's only one spot where that's true, and that's 4 pi over 3, and that would be our solution. Right? So to practice, let's have you guys jump over to, it's going to be homework 8, and I'll specify exactly which ones. I think I'm going to kind of have you jump around a little bit, but remember, I'm available from 11 to 1 every day if you need any help. Hey, I hope you have a good day.